Hello everybody, welcome back to the next video in the Project Euler archive series. Just a heads up, my cousin's drumming in the other room, so if you hear the drums, consider it background music. Today the problem is counting Sundays. You are given the following information, but you may prefer to do some research for yourself. January 1st, 1900 was a Monday. 30 days has September, April, June, and November. All the rest of 31, saving February alone, which has 28, rain or shine, and on leap years 29. A leap year occurs on any year evenly divisible by 4, but not on a century unless it is divisible by 400. How many Sundays fall on the first of the month during the 20th century? So from January 1st, 1901 to December 31st, 2000. So the way I'm going to go about solving this problem is just a straight up implementation of a calendar. We're going to start at the beginning date and just go all the way to the end date, keeping track of how many Sundays there are. So the first step in doing that is at some point I'm going to need to figure out if the current year is a leap year or not. So I'm going to write a function called leap, takes in a year, and it returns true if it's a leap year and false otherwise. So like the prompt says, like the question says, if it's divisible by 4, so that's the first thing we're going to check for. If year mod 4 equals 0, then it's a leap year. But that's not entirely true because there is a secondary condition. If it's a century, it's not a leap year unless it's evenly divisible by 400. So if year mod 100 equals 0, it's a century, we are going to return false if it's also not divisible by 400. Mod 400. Right? So turn false there. If the year is divisible by 4 and, if it's divisible by 100, it's also divisible by 4. So if the year is divisible by 100 and it is not divisible by 400, then it's not a leap year, as it says here. But if it is divisible by 400, then it is a leap year. We return true. Okay, and then at the end of this function, if this wasn't true, then we return false. Okay, so that's that. And now for the implementation of the calendar, there's going to be certain things we need to keep track of. So like variables, we're going to need to keep track of the month, the year, the day of the week, and the date of the month. So I'll write those here. We have the day. 1 is going to represent Monday, 2 represents Tuesday, and so on, and 7 is going to represent Sunday. Okay, so that's the day. We're going to have a year, which is currently 1900. We'll have a month, which goes from 1 to 12, and we'll have a date of the month, which starts at 1. Also, we need to keep track of how many Sundays fall on the first of the month. So that'll be our answer at the end of all of this. Okay, so while the year is less than 2001, we do a bunch of stuff. So let's do it. First, we're going to check if it's a Sunday and it's the first of the month, because that's the whole point of the problem. So if day equals 7, which is Sunday, and date equals 1, it's the first of the month and it's a Sunday, then Sundays plus equals 1. Okay. And now we need to just update all of those variables. So we'll need to update the day, we'll need to update the year, the month, and the date. So the day, pretty straightforward. It's just going to increment by 1 unless it's 7, because then it has to reset back to 1. So if day equals 7, we reset it to 1. Otherwise, we increment it by 1. For the year, we only update the year if it's December 31st. Otherwise, it stays the same. So if date equals 31 and month equals 12, we increment year. And for the month, this one's a little trickier because we need to figure out how many days there are in the current month. So let's say days in month. And again, this is going to change depending on the month. The ultra special case for days in month is going to be February, which doesn't fit any of the rules of the other month. So let's say if month equals 2, then figure out days in month. So let's think about this for a second. If it's February, the days in month, I'm just going to talk English here, no coding. The days in month equals 29 if it's a leap year, or 28 if it's not a leap year, right? That's it, pretty simple. Well, since Python is so crazy, you can just basically type in English and it will understand what you mean. So days in month equals 29 if it's a leap year, our function above, else 28. Isn't that lovely? Yes, I know. Okay, else days in month equals, I'll just say English again. I want days in month to equal 31 if it's one of the months that has 31 days. Otherwise, I want it to equal 30. So we'll have to make a variable to tell us which months have 31 days. So I'll say 31 days. I don't know if you can do that, if that's legal to have a number there. I'm going to say extra days. Okay, so the months where 31 days are January, March, May, July, August, October, and December. So if it's not February, the days in month equals 31 if month in extra days, else 30. All right. Now you have our days in month. Now we only update month if it's the last day of the month. So if date equals days in month, then we have to update month. Month will increment by 1 if it's any month besides December. So if month equals December 12, then we reset it back to January or 1. Else month increments by 1. Okay, and the date, we can use this if statement for that, because if it's the last day of the month, then we reset date back to 1. And otherwise, if it's not the last day of the month, we just increment it by 1. Okay, so this should do the trick. This kind of goes through, updates all of the variables properly, and if it's a Sunday and it's the first of the month, then we increment Sunday by 1. So let's see if that spits out the right answer. Print Sundays. Okay, we got 173. I know that's not the right answer because I forgot to do one thing. The question asks us from January 1901, but we're starting in 1900. So I'm going to add a third condition here and only increment by Sundays by 1 if it's a Sunday, if it's the first of the month, and if the year is greater than 1900, to not include those first couple of Sundays. Okay, and we got 171. I've already done this problem before. As you can see, that is the correct answer. Yep, there you go. That's counting Sundays. I'll see you in the next video.